$1 million in prize money is on the line in the first ever head-to-head autonomous racing event to be held at the Indianapolis Motor Speedway in October. UVA Engineering's Cavalier Autonomous Racing Team will compete with other top universities for bragging rights as the best autonomous racing team in the world. Buckle up as I, your host, Chris Tyree, and UVA Engineering professor Madhur Bahel take you in the shop, under the hood, and around the track in this new world, pushing autonomous vehicles to their limits. Good to see you again, Madhur. How are you doing?
I'm doing good. Yeah, good to see you too, Chris.
Awesome. So before we get into talking about today's topic, just can you bring us up to speed on where the group is at?
Yeah, so since last time we spoke, we've been pretty busy trying to improve our autonomous driving stack because we are in the final stages of the simulation phase of the Indy Autonomous Challenge. And so my team and I, we welcomed some new members, first of all, between, when we spoke last a couple of weeks ago. And so our team has grown now to 16 students. And we've mostly been focusing on improving the multi-agent overtaking algorithm, right? So previously, previously, the ability of the race car, at least in our software, we could handle one another car on the track and make sure that at high speeds, we, even if we could get close enough to the car, we don't, rear end it, or if we saw a wide enough gap, we make the strategic decision whether or not to attempt the overtake and take that risk essentially. But the simulation race will feature many, many opponents. I believe it could be up to 8 opponents at a given time. So it's a pretty, packed track, and it's becomes 8 times difficult to race because you have other agents around you which are also trying to impede your progress, right? So the tricky part about multi-agent racing or driving is in racing in particular, everybody has their elbows out and they won't let us pass. There's no concept of yielding as such. So we have to adapt our methods to firstly understand this rich scene with many, many different cars and not just one another car. And also then, fall back into determining when is it a good time to go for it and try to thread the needle, as they say, or take it safe and wait for your opponent to make a mistake. So there's very exciting, very challenging problems, and we are slowly kind of moving in the phase where we race against our own algorithms, we race against choreographed vehicles, we race against vehicles which are programmed to be erratic to kind of stress test our own stack. And so that's really what the team has been focusing on. Yeah.
Oh my gosh. And is this at scale? Like when you're talking about doing this virtually, is the car at scale to what you're going to be racing?
Right. So the simulation platform, which is being used for the race, it has a very realistic model of what the race car is going to look like. Where the sensors are going to be placed. We have sort of precise locations of them. And then the underlying physics is close enough. There's always going to be a sim to reality gap, which everybody is aware of. And especially when it comes to tricky things like aerodynamic effects or looking at the traction of the wheels, and track conditions will change in the real world. In the simulation, we sort of hand wave over these aspects of the car. But for the most part, the emphasis is to really design these algorithms which can plan trajectories among the presence of many other agents who are trying to compete for the same race line, for the same strategic position in the real world. So all of this will have to be transferred to the real car come end of May or June this year. And that's where the bulk of the effort is going to be, to make sure that whatever are the gaps between simulation and reality, our algorithm is aware of that, and we have plugged those gaps in some manner and addressed that. Yeah.
Oh, fantastic, exciting! And so, when is this race and this big race happening?
So the simulation race is going to be held at the end of May. I believe it's in the same weekend as the real Indy race car. So when the weekend is over, then they'll have like a big event of a sort, and the simulation host and the organizers, they will replay some of the laps of the simulator. And I also think we'll have to wait until that time to find out how well we did in the simulation part. There's some prizes for the top 2-3 teams for the simulation phase. So we are looking towards the last week of May for that to take place. Yeah.
Oh, exciting. Oh, so a lot going on. Is anybody losing sleep yet? You've got new members. How's that been to gel that team?
Yeah, so that's probably the most exciting part of what I like about this competition is working with the students, and so I let them sort of take control of the algorithm and where they want the team to move, and so we are always looking for very sharp people to be part of the team, and it's like an open call went out. We got many applications. There was a little bit of scrutiny, and we look for people who have a certain background in place because they can hit the ground running or rolling in this case. We spend a little, we have our own internal weekly meetings, team meetings, and in the previous one, for instance, one of the senior and students on the team, he acclimatized everybody else with all the intricate details of the simulation, right? So there's a little bit of baselining or orientation for new members, so they can contribute and bring their own skills and strengths to the team as well. But yeah, I think that's gone pretty well so far. It's been we've been able to get everybody up to speed pretty fast, and so from now, it's mostly. You spoke about losing sleep. I've been losing sleep over this for years now, so this is nothing new for me. But yeah, I think we are getting into that crunch time of the competition where we really need to make sure that we know where our algorithms might fail and what are we provisioning, if and when we encounter those situations in the simulation.
Yeah, better to do it in the simulation than with a very expensive fast car moving around Indy.
100%. Yeah, I mean you can crash for free in the simulation, and the cost of entry is just embarrassment. Nothing is getting physically lost, and that's sort of the mentality behind this 110 scale race car as well that you see behind me. You could crash this, and it's relatively cheap. We have dozens of these in my lab, and really, I've said this before that. You want to operate at the limits of control. And so the only way to know that is once you cross over, you'll crash or drift out. In the track, the configuration is very unforgiving, right? So in the Indy track, where we'll be racing, there's a concrete wall throughout the oval on the right-hand side. So there's literally no room for error. And if you make the mistake of touching that wall at anything at high speed, then you're looking at some downtime. Hopefully it's a repair that you can make trackside, and we'll have help from the organizers to sort of figure that out. But yeah, I mean, if you crash head on into the wall, that's game over and years of, so we definitely don't want to do that here. And so leading up to the real race, we'll have some actual track time, practice days on the Indy track and like a local track as well, where we intend to travel to Indy over the summer to get familiar with the car itself, the hardware. And there's a lot of, know-how and domain expertise which has to be transferred. So Delara, which is providing the vehicle, is going to maybe give an orientation of Know Your Vehicle day or a workshop related to that. And we'll interact with real Indy drivers to get their thoughts on how do they perceive risk, when do they decide to overtake. That's really what we're trying to encode at the end of the day, the craziness of a real race driver. So getting some face time with them would be also very useful.
Wow. Well, so you guys will plan to be in Indy to do all that sometime in the beginning of June, late May or so?
Yeah, there's a calendar laid out because Indy is a pretty popular track, so we can't just show up whenever we want. So there's some specific dates where we have practice teams, and all those teams who will get the real vehicle, will timeshare those weekends or 3 or 4 days. But a lot at the end of the day, I think it's all going to come down to transferring this knowledge from simulation to the real world and addressing these real world complex, messy problems that some of them we haven't even thought of yet. And so the more track time we can get, and it's not like we are going to go there and start racing at 100 miles per hour on day one. we'll slowly bring our car and move it through the paces to gain confidence that it is behaving as expected. So we can, up the ante a little bit and go into higher gear. But yeah, I think it boils down to putting in the work and getting as much track time as possible to work through every possible issues and not just let things hang in there for the last second. So we want to freeze our development as well. I think that's very key.
So you're going to be taking your virtual experience, transferring that to the track, to a real world experience. And here I am in a whole new world here on Mars. And right over my shoulder here is Integrity, a helicopter. This obviously hasn't happened yet, but it's going to be happening soon. And this sort of begs, what you're doing and what all these teams are doing is really helping us prepare for the future, right? Helping us to think about how we build these autonomous cars to be safe in an everyday use. Can you talk a little bit? I know this is exciting for you. We've talked about this before offline, but you're very interested in this. You've got an experience in space and an interest in stars and taking pictures. What is this like for you? How does this feel?
It's exciting, like with the most I feel. I mean, you're right. I have always had an admiration and affinity for NASA and what it does in terms of exploration in space. I dabble with sort of astrophotography myself a little bit. And because, of my keen interest in robotics, it's just a natural fit. And it's, it checks off all my boxes of sci-fi and everything. So it's definitely very exciting. I think it's remarkable to also first recognize that the Perseverance landing was just nothing sort of amazing, right? So the very fact that we can do this now on almost like a regular basis, strap on a robot in front of a rocket and send it to a planet. But not just that, we can do this with such high precision and ease. So I don't know if you saw, Chris, the multi-cam footage of the landing that they released a few weeks ago. Oh my gosh, that was probably the most amazing video I've seen in a while, because it's, we are used to seeing the concept in CGI and how they envision it will land on the Mars, but bang, there was the chute opening and the heat shield is separating. And then there's this almost like an intricate crane maneuver where it's hovering above the surface of Mars.
I mean, come on, that's amazing. Who even thinks that up? I mean, you engineers do.
It's amazing. And then it sort of caresses the robot onto the surface. It's almost this, beautiful choreographed sequence, which played out exactly how the engineers and scientists predicted and programmed for it. And so that just on its own is just amazing. And I can't wait for all the science that comes out of this rover's program and mission. And then you nail it, right? So the crazy part, if all of the previous stuff is not crazy enough, then a million things could have gone wrong in that, but nothing did. And they behaved exactly how it did. And in the underbelly of this rover lies a rotorcraft or a helicopter, which is going to be demonstrated and be flown above the surface of another planet. And I think that's going to be a sort of a very big moment in the history of space exploration, no doubt. And we'll see how well it goes. I have full confidence that, they'll be able to be successful in the flight. I think they are waiting for, and this is again, attention to detail, which is similar to our own mindset when we program our cars and everything, right? So every single piece has been well thought out, that they'll drop this rover, the Perseverance will move away from it, further away so that the cameras can see the rover and the flight itself. And then I think they'll leave it for a day or two to get charged by the solar arrays, because it has to be kept warm and whatnot. There's so many challenges in operating on this alien environment. And then at the end of the day, it's really like, the first powered flight on a different planet. I think there's been some missions, I'm not sure which ones, where some balloons were launched to do flight in exploration in space, but nothing in terms of a powered flight, right? So if you think about it, really, it has taken us somewhat close to 100 years to go from the first manned powered control flight by the Wright brothers in the sort of early 20th century to now a powered controlled flight on another planet. I think that is an accomplishment of humans, and NASA gets all the credit for it, as they should, but everybody should be proud of this accomplishment. And it will literally and figuratively launch a new dimension in terms of space exploration, because now you can survey large areas at once, and you don't have to crawl your robot to investigate some interesting crater or artifact on the planet itself. So yeah, I'm super excited. I'm going to be following very closely, as I normally do. I have been bitten by the space bug a long time ago, and I wish the team entire success towards this first demonstration of flight. Yeah, I was thinking, we have now become the species which is sending UFOs to other worlds. Okay, so if there was a Martian somewhere hiding behind a rock, they would look at this and say, "Oh, look, what is that? Is that a UFO on my planet? And who's sending that?" So that is just astonishing. Yeah, it will never cease to amaze me how well this works here.
How does what we've done in the past sort of relate to what we're seeing now, and what does that bode for our future?
So actually, interestingly enough, I've been watching this TV show. I don't know if you have heard of it or seen it. It's called For All Mankind.
Oh, yeah.
And the main sort of plot hole, without giving much away, is if the space race had continued beyond the 60s and the 70s, what would space exploration look like? And so that's a very interesting setup, and your question sort of relates to that. In many ways, we may have taken more time to get where we are today, but the trajectory is more or less sort of what that show depicts. But they have, moon colonies and whatnot. We aren't there yet. Hopefully, in our lifetime, we can see, some of that takes shape as well. But the root of your question is what I think today, or this time is, in my opinion, one of the best times to be working in autonomy and to be working in robotics and autonomous systems, not just because of space exploration, but if you just look around us, right? So AI and robotics and autonomous systems, they are everywhere, and they are, permeating the very fabric of society that we live in. And they are shaping the future as well. And the future of automation is one where I think, it can go in many different directions based on the kind of developments and the pace of developments that we have been seeing. So if we go for a second back to this rover and entire space exploration and robotics, NASA as an entity is comprising of mostly scientists and engineers. So they behave very much like academics, and so like a large university or an institution which is spread across, and so they share a lot of the same mechanism of progress, where some prototype or an idea is presented. It may be outrageous at some point. So remember, think of being in the room where someone proposed, "Oh, let's send a crane which will hover," and then a sequence of cables is going. That's not something people would have a sort of tendency to say, yeah, that's foolproof, right? So because there's so many moving parts. But again, through, I think, years of research and testing and developing algorithms and prototypes, you can show that this idea has some footing. It's not just a sum of fantasies, the total fantasy, but once you start providing evidence, which is the bare bones of scientific research, that we just don't operate on opinions and hunch. We look for empirical evidence and data before we are convinced that this thing can be deployed in the real world. So that has been the case in all of autonomy and robotics. Just to think of some examples, and it's a two-way street, right? So to give you some examples, the rover itself, has to navigate the terrain of an unknown planet. And so how do you do that, right? How do you say, I want to go from my current location to some interesting rock or artifact that I want to explore, but nobody's joysticking the robot on Mars. So it has to figure that out. And so it's relying on years and years of research in motion planning. And people have developed algorithms which approximate unknown areas with grid cells, and the robot kind of produces many paths and then assigns a risk or a cost to what would be a desirable path. And that's very similar to how a self-driving car works, right? So the common DNA among any robot is that it always has to do three things, Chris. So it always has to solve the problem of perception, which is how do I sense my surroundings and make sense of what is around me? Where am I in my environment? Where are other agents in the environment? So for our self-driving vehicles, that's like saying, where are you on the road with millimeter or decimeter level accuracy, right? So we can't be thinking that, oh, we are somewhere on this freeway. We need to know which lane we are in. And that's, requires some very intelligent algorithms to figure that out. You can't just rely on like GPS alone for that. And then you have to figure out, well, what is the world around me? So what are other cars? What are lanes? What are traffic signs? What are traffic lights? Where there's a pedestrian, there's a cyclist. There's a long list of things which can appear on the road. And some may even say that list is infinite. Maybe we don't know what can appear on the road at any time. So that's perception, that's sensing, and we have to develop the scene understanding, just like this rover is doing on Mars. And then comes planning, because once you have understood the scene, you have to figure out where do you have to travel in the real world, right? So what is your own plan of action? What is your own trajectory that you want to follow in the near future? And we're talking maybe 1 second or 2 seconds for the case of a self-driving car. And then the final piece of this is control, where you execute the motors or the steering command, the acceleration, the brake to follow your plan safely, right? So things can change while you are following the plan. So you have to continuously loop from sensing to plan to action, also from perception to planning to control. And every robot, I don't care whether it is on another planet, whether it's on the road, whether it's in the air or a self-driving submarine underneath the surface of the ocean, it's always solving this loop of perception, planning, control. And really the decades of research in robotics have contributed to each of these areas, because there's many, many things which can go wrong in perception and planning. And so we build up on that. And then the other direction is we learn from these robots operated in being operated on the frontier of research, right? So the Ingenuity rotorcraft is going to operate in a completely unknown environment, 1% atmosphere, 30% gravity. So we learn from that, and that will translate into some benefits in our own flight programs on Earth, right? So like flying on the surface of Mars is like sending a helicopter to 100,000 feet, which has never been done, right? So we learn from that. And so similarly, racing is the frontier for self-driving cars. And so we are hoping that by exploring this limits of control and operating at the edge of how well can you solve this perception, planning, control while going at 180 miles per hour, the hope is that this will result in knowledge and understanding of self-driving algorithms, and it will have a huge bearing and a significant bearing on the safety of self-driving cars. Yeah.
Let's go.
Wow. It's out of this world, man, really. I'm so impressed. And I'm just excited about all that that you're doing and your team is doing, and we'll be watching over the next week or so or two on the Red Planet to see how this works out. It's thrilling.
I'm lightning like Steve McQueen. I'm in the fast lane when the light turns green, and I built tough. I ain't nothing but grit, 'cause I made rugged blood, sweat, and spit.